Are you ready for some shocking news? NASA has just announced that the San Andreas fault has cracked, and it's going to cause record flooding. This announcement is causing widespread anxiety throughout California, as experts investigate whether the fault may be at risk of a significant earthquake. In this video, we'll take a closer look at the potential devastation that could occur, as well as the measures being taken to prevent it. Stay tuned until the end to find out how you can stay safe if an earthquake were to occur. Experts are investigating whether the San Andreas fault may be at risk of a significant earthquake, as reported by the LA Times. The recent 7.8 magnitude earthquake in Syria and Turkey, which claimed the lives of nearly 50,000 individuals, has raised concerns that a similarly sized earthquake could strike America. The San Andreas fault, a sliding boundary between the Pacific and North American plates, runs through California, including San Diego, Los Angeles, and Big Sur on its Pacific plate, and San Francisco, Sacramento, and the Sierra Nevada on the North American plate. The fault has experienced at least 5 earthquakes, with the first occurring in 1857 and the most recent in 2004, with a magnitude of 6.4. Despite typically causing little alarm among Californians, the possibility of an earthquake in the southern part of the fault, which is reportedly highly active, has caused considerable concern. Thomas Jordan, director of the Southern California Earthquake Center, has confirmed that the risk of a significant earthquake is high, causing widespread anxiety throughout California. Thomas Jordan's candid and detailed descriptions of the upcoming catastrophe are not helping the situation. While some may have preferred a more optimistic portrayal, it is important to consider why Jordan's predictions are worth heeding. In the past, earthquakes were believed to be acts of God, but now we understand that they are a natural phenomenon that occur on a planet as large as Earth, with human actions playing a role as well. While earthquakes were once thought to be unpredictable, the Chinese catastrophe changed this perception to some extent, although it is still difficult to predict earthquakes accurately based on universal characteristics. Given the potential for destruction in affected areas, expertise in seismology is crucial, allowing for near-accurate predictions and the ability to identify false negatives. In the case of the southern part of the San Andreas fault system, no major release of stress has been recorded since 1857, which makes the current situation especially concerning. While the northern part has experienced some stress relief through previous earthquakes, the southern fault has not. With such a significant buildup of stress over a long period, an earthquake in this region could be extremely catastrophic, and the imminent question is just how devastating it will be. The movie San Andreas, produced by Beau Flynn and directed by Brad Peyton and Carlton Cuse, portrays a hypothetical earthquake of magnitude 9.0 striking Southern California. Although this is scientifically unlikely in the region where 2 tectonic plates slide past each other, it is still possible in regions where subduction occurs. Reputable scientific organizations have determined that the maximum earthquake magnitude that can strike along the San Andreas system is 8.0, with a 7% probability of occurring in the next 30 years. However, even a magnitude 7.0 earthquake has a 75% chance of striking. The movie's portrayal of the San Andreas fault as being beneath the ocean and opening up a massive chasm is not scientifically accurate. Despite the likelihood of a magnitude 7.0 earthquake, the devastation would still be significant. Understanding the 1857 Fort Tejon earthquake, which caused significant property loss and 1 fatality, can provide insight into the potential devastation of an 8.0 earthquake. Unfortunately, a woman lost her life when an adobe house collapsed in Gorman during the earthquake. The earthquake lasted between 1 to 3 minutes and was felt from Sacramento to the Colorado River Delta, resulting in sand blows and hydrologic changes in the Los Angeles-Santa Ana and Santa Clara rivers, as well as Santa Barbara. Brown fish were observed in Santa Barbara and the floodplain of the Santa Clara River due to the sand blow shrinkage. There were reports of liquefaction in the area between Stockton and Sacramento. In Northern California, San Diego, Santa Barbara, Isabela, and the south end of the San Joaquin Valley experienced changes in the flow of streams or springs, and changes in the flow of wells were also reported. The overflowing of the waters of the Kern Lake, Los Angeles, and McCollum rivers raised concerns about flooding. The earthquake had aftershocks, with 2 notable ones on January 9th and 16th that was widely felt. Although history is valuable, as Heraclitus of Ephesus once said, "No man ever steps in the same river twice, for it's not the same river, and he's not the same man. Therefore, we need to conduct a new analysis based on possible scenarios to understand and predict any future earthquakes. The U.S. Geological Survey has taken up this challenge, modeling a 7.5 magnitude earthquake with slippage of 2 to 7 meters to represent the long stress release drought in the fall. Construction straddling the fault would be the most effective preventative measure. But unfortunately, there are few such constructions following the Alquist-Priolo Fault Zoning Act. As a result, over $33 billion would need to be spent, which could weaken the world economy as trade may stagnate. Although modern houses are generally less susceptible to earthquakes than old houses, not all old houses are vulnerable. Some old houses have been equipped with anti-earthquake technology, but many have not, and therefore are likely to be affected in the event of an earthquake. Furthermore, the aftermath of an earthquake can be exacerbated by fires, as was the case following the Northridge earthquake. Given the potential for gas mains and water pipes to be severely damaged, forecasts suggest that the damage from fires will exceed the damage from the initial earthquake. The death toll could be as high as 1,800 if people do not evacuate in time. Aftershocks are also a concern following an earthquake, as the tectonic plates are destabilized. For example, Christchurch, New Zealand, experienced over 10,000 aftershocks after a 6.2 magnitude earthquake in 2011. The San Andreas Fault is similarly likely to experience many aftershocks. Additionally, Los Angeles may face a water crisis if the aqueducts from the Colorado rivers, Owen Rivers, and the Sacramento-San Joaquin River Delta are blocked by the earthquake. More than 88% of Los Angeles' water supply comes from these aqueducts, which cross the San Andreas Fault about 32 times. If the big one strikes, more than 22 million people could be left without water. In order to be ready for the earthquake, Mayor Eric Garcetti of Los Angeles has proposed a number of solutions to protect the water supply and develop alternatives in case the aqueducts become blocked. A comparable amount of effort has been put forth in the San Francisco Bay, which has resulted in the construction of backup tunnels, stronger pipes, and new waterways in order to ensure the water continues to flow from the Sierra Nevada. Among the preparations that are being made for the large earthquakes are the retrofitting of buildings that are susceptible to damage and ensuring that internet connectivity will be maintained after the earthquake. In light of the fact that the earthquake could cause widespread destruction, it is highly likely that a sizable amount of resources will have to be allocated to the reconstruction effort that will follow. The Los Angeles Aqueduct, which was built by William Mulholland several decades ago, would be the place to begin in this ideal scenario. It travels through the Elizabeth Tunnel, which is 5 miles long and is located beneath the mountains to the north of Santa Clarita. This route crosses the San Andreas Fault. In spite of the fact that it has stood the test of time, it has never been subjected to a serious earthquake. The fault could move up to 33 feet as a result of a significant earthquake, which could cause the pipeline to sustain damage and cause some of its concrete sections to be destroyed. This is according to predictions made by experts. As we've learned, the San Andreas Fault is a ticking time bomb, and the risk of a significant earthquake is high. While we cannot predict with certainty when it will happen, we can take steps to prepare ourselves and our communities. It is important to stay informed and educated on the latest developments, as well as have an emergency plan in place for you and your loved ones. Remember, earthquakes are not just a California problem, but a global one. Understanding the science behind earthquakes and the potential impact they can have is crucial for building a safer future. Let's work together to raise awareness and take action to mitigate the devastating effects of earthquakes. Thank you for joining us today, and don't forget to subscribe to our channel for more informative and engaging content. Stay informed, and we'll see you in the next video.